So let's talk about our angles of elevation and depression, bearings and triangulations. So first off, let's talk about angles of elevation and depression. So you've been talking about these for several years. So hopefully this should just be a recap. Now, the major thing to remember is that we always measure the angle of elevation depression from a horizontal. Okay, it's always from a horizontal line. So here is our angle of elevation. That horizontal line is the ground. And that's where we measure that angle of elevation from the ground up. Most students are okay with that. But it's here when we get to angle of depression. So we have this imaginary horizontal line out here from the person, and then this line of depression where they're looking down towards the boat. And that there is the angle of depression. It's measured from the horizontal down to that line. It's always measured from a horizontal. Okay, it's not there, it's here, measured from that horizontal. Now, a good thing to remember is, you probably remember with your rules about parallel lines and angles and things, that angle there is the same as that angle there. Okay, so they're actually the same size. All right, so when you come to do your triangle work, it becomes all a bit easier there for you. So, the angle of depression from the top of a 35-metre cliff to a house at the bottom, we always get these cliffs in angles of depression and elevation, is 23 degrees. How far from the base of the cliff, base means bottom of the cliff, is the house, correct to the nearest metre. So we always draw a diagram of the situation. So here is, a diagram of a cliff with a house and showing that 23 degrees. Then you might want to draw a separate diagram here of the triangles. So not, quite so realistic, but really just down to the triangles, because I know once we get it down to the triangles, you don't find it quite so difficult. So here, we're really looking at a right angle triangle. Okay, so that's 23 degrees there. So that must be 23 degrees there. We know that the cliff is 35 metres high, but we don't know that distance at the bottom there, and that's the one we're interested in. Okay, so we've got it down to a triangle where we have an unknown, and so we just use our normal SOHCAHTOA knowledge. Now, I have to admit, most of the time with angles of elevation depression, we use tan theta, but not all the time, but most of the time. So we've got opposite and adjacent, and we've worked it out there. So that distance is 82 metres. So from the 2017 Northern Hemisphere Exam 1, this was a question 2, so that's early on, so it's meant to be straightforward. A vertical tree, so up and down, of height 20 metres stands on horizontal ground. The tree is 100 metres away from point P, as shown in the diagram below. Okay, so 20 metres high and is 100 metres away. Now, a lot of the time when students are drawing these diagrams, they get confused when they see something like 100 metres away. Now, that implies that it's this horizontal distance, okay, not that distance there. That's, we wouldn't say that's 100 metres away. We'd say, if we had to walk it, we're walking this, aren't we? We're not walking in the air, we're walking this. So that's 100 metres away and 20 metres. The value of angle X shown in the diagram above is closest to. So we have opposite and adjacent, so that means the tan angle equals opposite over adjacent. So tan x degrees equals 20 over 100. So I'll get my calculator. So inverse tan of 20 over 100, control enter to give me approximately equal to, so x is 11.31 degrees. So that makes it closest to 11 degrees B. And yes, that was correct.